This is a section of a newborn knee joint, stained with the periodic acid shift reagent, or PAS, for carbohydrate to emphasize the matrix of cartilage and bone. Cartilage appears an intense magenta. That which is calcified is even darker. Bone tissue, down here, stains paler because it's got much less carbohydrate, and the cells stain very poorly. First of all, identify these two opposed masses of hyaline cartilage. One is the head of the femur, the other is the end of the tibia. And at this stage, these bones have only a single ossification centre. Later, they will develop a secondary centre here in the middle of the masses of reserve cartilage. Since these cartilaginous masses include the epiphyseal ends of the bones, scanning along them will show all the stages of endochondral bone formation. I'm going to describe this process viewing this region here in higher magnification, which is just adjacent to the zone of reserve cartilage where growth is going to begin. So proceeding down the future shaft of the bone, here is the zone of cell proliferation, where the chondrocytes reproduce by specialized cell division. The division planes are all in the same orientation, resulting in flattened cells arranged in columns like stacks of coins. One cell in the reserve cartilage divided to produce all the cells in one stack. Next is the zone of enlargement, along here. The cells swell up into an almost spherical shape. After this is the zone of calcification. The chondrocytes die as they calcify the matrix around them, and you can see the empty lacunae. A front of chondroclasts covers the exposed surface of the calcified cartilage matrix in this zone of resorption. These cells remove most of the matrix, except a few bits which remain as elongate spicules extending into the marrow cavity. Chondroclasts are the same cell type as osteoclasts. They're just eating a different dinner. These chondroclasts are difficult to recognize here, in part because the tissue was stained with the periodic acid shift reagent instead of hematoxylin and eosin, and in part because their cytoplasm is filled with unstained vesicles, making the cells look like balls of pale foam. The surviving spicules of calcified cartilage protrude into the marrow cavity as the zone of ossification. They form a firm substrate for osteoblasts to attach to. These cells are lined up on the thin, almost black calcified matrix. The nucleus is pushed to the side, and the large pale-stained area of cytoplasm you can sometimes see is the very active Golgi apparatus. Some of the nearby spindle-shaped cells are osteoprogenitor cells, but they can't be distinguished with certainty from the reticular cells that support the bone marrow between the spicules. The osteoblasts produce a thin layer of pink woven bone over the cores of dark purple calcified cartilage matrix. The layer of bone gets progressively thicker towards the lower end of the spicules. Multinucleated osteoclasts sit at the ends of the spicules and chew their way upwards. They keep the length of the spicules more or less constant while the marrow cavity enlarges. This is how endochondral bones grow longer. To understand what is going on the bone spicules, it's important to realize that the cartilage matrix is polarized and that cells can distinguish the longitudinal direction from lateral directions in it. This polarity is obvious up in the zone of proliferation, where the cells divide only longitudinally to form stacks of disc-shaped cells. It persists in the spicules of the zone of ossification. Osteoblasts are attracted to the lateral sides of spicules by signals that are currently unknown. Osteoclasts are somehow attracted to the ends of the spicules and to the surface of newly calcified cartilage in the zone of resorption, where they can chew their way upwards towards the articular end of the bone. The diaphysis of the bone is also growing under the periosteum. The osteogenic layer of the periosteum is made up of large, easily visible osteoblasts. They secrete bone onto the outer surface of the cartilaginous diaphysis to form a bone collar. Simultaneously, osteoclasts in the marrow cavity remove bone from the inner surface to enlarge the marrow cavity. Because osteoblasts deposit new bone directly onto existing bone under a periosteum without any involvement of cartilage, the diaphysis is considered to grow intramembranously. So, a long bone, such as the femur, is formed through both endochondral and intramembranous bone formation. Flat bones are formed only by intramembranous osteogenesis.